today is talking about the ellipse. So the ellipse, again, is a conic section. Right here you can see I have a little GIF of how an ellipse is created. Basically what it is you have 2 points there called the foci, and then you connect them with a string, and then stretch that string out. The furthest you can get away from each, by keeping the string taut as you go around in a circle, or well, not quite a circle, obviously, an ellipse, but as you go around, that ends up being the shape. So that's kind of a nifty little diagram of how that's constructed. And a circle is just a special type of ellipse, basically where the foci overlap. But an ellipse is another conic section. Again, it's taken when you take the shape of a cone, and then you intersect it with a plane at an angle like that. So, and we're looking at the overlap there, which is an ellipse. And again, the use of this is handy in, the orbits of the planets are elliptical, and things like that. So let's go ahead and get started. So an ellipse is a set of all points P in a plane, the sum of whose distances from 2 fixed points F1 and F2 is constant. So again, here's kind of a way of drawing it. But the idea is that this string is constant. So this distance plus this distance has to always be the same. So these 2 fixed points are called the foci, or the focus for individually. The midpoint of the segment connecting the foci is the center of the ellipse. Points where the line through the foci intersects the ellipse are the vertices. The line segment that joins the vertices is called the major axis. Line segment whose endpoints are on the ellipse and that is perpendicular to the major axis at the center is called the minor axis. So the major axis is the long one, the minor axis is the shorter one. All right, and also a lot of times we can call these points here co-vertices. The points that are on the minor axis, you can call them co-vertices. It's kind of nice because usually when we're graphing, we'll find the vertices and the co-vertices. And again, it's singular, it's vertex and co-vertex.
So we can derive this pretty much the same way as how we did the parabola, but it's a little bit harder to do. So, but let's just go ahead and use this formula and look at what D1 is this guy here, D2 is this guy here. So D1 is going to be square root of x plus c squared plus y minus 0 squared. And D2, this guy, is going to be x minus c squared. And then y minus 0 squared is going to equal 2a. All right, so let's just go ahead and subtract this second radical from both sides. So we get 2a minus square root of x minus c squared plus y squared. Now let's square both sides. So I get x plus c squared plus y squared. And this one we got a FOIL, so it's not very pretty. But we end up with 2a squared, so 4a squared, minus, and we're going to have 2a times that, minus another 2a times that, so minus 4a times the square root of x minus c squared plus y squared, then plus the second part squared, which is just going to be, get rid of the square root, x minus c squared plus y squared. All right, so when we do that, notice plus y squared, x, that one doesn't quite cancel off yet. So x, that was minus c squared. All right, so now let's multiply this x plus c squared out to x squared plus 2cx plus c squared equals 4a squared minus 4a square root of x minus c squared plus y squared plus x squared minus 2cx plus c squared. I know this is kind of a mouthful here, but now I can subtract x squared from both sides. I can subtract c squared from both sides, and I can add 2cx to both sides. So I end up with 4cx equals 4a squared minus 4a square root of x minus c squared plus y squared. What we're trying to do here is simplify it down so we can square it again and get rid of the remaining square root. So we can divide everything by 4, and we get a squared minus a square root of x minus c squared plus y squared. So now let's go ahead and let's factor out an a. Actually, I'm not sure we want to do that. Yeah, actually, instead, let's subtract that a squared from both sides, because we want to kind of get this square root by itself. So equals negative a square root of x minus c squared plus y squared. Now let's square both sides again. So I get c squared x squared, and then minus 2 a squared cx plus a to the fourth equals a squared times all of this guy, x minus c squared plus y squared. So now let's go ahead and simplify the right side here. So the left side, let's just leave unchanged here. So I get x squared minus 2cx plus c squared plus y squared. Let's distribute that a squared through. So I get a squared x squared minus 2a squared cx plus a squared c squared plus a squared y squared. All right, so let's see what we can do for simplifying here. So I got a minus 2a squared cx minus 2a squared cx. Those I can add those to both sides and take care of that. So I got c squared x squared plus a to the fourth equals a squared x squared plus a squared c squared plus a squared y squared. So let's get all the stuff with x's and y's on one side and stuff without on the other. So I'm going to subtract this guy from both sides, and then I'm also going to subtract this guy from both sides. So I get a to the fourth minus a squared c squared equals a squared x squared minus c squared x squared plus a squared y squared. All right, we're almost done. Trust me. So these on this left side, both of these have an a squared. Factor that out, and I get a squared minus c squared. On these, they both have an x squared, so let's factor that out, leaving me with an a squared minus c squared. And we still have a squared y squared here. Finally, let's just use this little substitution here. Let's let b squared equal a squared minus c squared. So then I'm going to have a squared b squared equals x squared b squared plus a squared y squared. And now let's just divide both sides by a squared b squared. So when I do that, I'm running out of space here, but when I do that, I end up with 1 equals x squared over a squared plus y squared over b squared. And that right there is the formula that we need to use. So, are you going to have to prove that to me at any time? Absolutely not. But if you want to, that's how you do it. All right. Now, how do we use that? Well, the quick answer is the number under the x tells me how far left and right to go. The number under the y tells me how far up and down to go. And I should be clear, it's the square root of that number, right? So a and b, but they're squared in that equation. So standard form of the equation of an ellipse with center at the origin and major and minor axes of length 2a and 2b respectively. The vertices are these guys here. The vertices on the major axis, a units from the center. The foci are on the major axis, c units from the center. For both equations, b squared equals a squared minus b squared. Or if I solve that for c squared, it's a squared minus b squared. And I kind of like to think of this as just bigger squared minus the smaller squared. I don't really even keep track of what's a and b and stuff in these necessarily. I just kind of, again, this needs to be positive, so I take the bigger minus the smaller. All right, so now that your head's spinning from that derivation, let's try and simplify it down a little bit better. Let's make sure we understand the three different things. We basically need to know what a means, we need to know what b means, we need to know what c means. So the number under the x, the square root of that tells me that distance there. The square root of the number under the y tells me that distance there. And then if I take subtract those two numbers, larger minus smaller, it tells me this distance here. And that's all there is to it. So let's do a couple problems, and I think it'll start to make more sense. So looking at this, graph x squared over 25 plus y squared over 9 equals 1, and locate the foci. So if I'm going to graph that, the number under the x is 25, square root of 25 is 5. So I'm going to go right and left 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then I'm going to go, the number under the y is 9, square root of 9 is 3, so I'm going to go up and down 3. C squared is equal to the bigger minus the smaller. So C equals 4. And the foci are always going to be on the major axis. And remember, the major axis is the longer axis. So since my x numbers were larger than my y numbers, I'm going to go left and right 4. So my foci are going to be right here and right here. So the foci are 4, 0 and negative 4, 0. All right, so now we just go ahead and there we go. And my apologies if you can hear baby in the background, but all right. So graph and locate the foci of this guy right here. So notice the equation of an ellipse is equal to 1, and that has to be the case. So before we start doing anything, we need to go ahead and make this equal to 1. So I'm just going to divide both sides by 144. So 16 goes into 144. Here. 9 times, I believe. So I get x squared over 9, and then this would be plus y squared over 16, and that must equal 1. Okay, so again, the number under the x is 9, so let's go left and right 3. The number under the y is 16, so let's go up and down 4. So our major axis is up and down this time, because the bigger number's under the y. So the foci, c squared, is going to equal 16 minus 9 equals 7. So c equals square root of 7. So I'm just going to go up and down square root of 7. So square root of 7 is somewhere between 2 and 3, right? Square root of 4 is 2, square root of 9 is 3. So let's just, if we're graphing it, let's just put it right about there. So I'm going to go up and down square root of 7. Let's connect our dots. Oop. And our foci then are 0, square root of 7, and 0, negative square root of 7. So notice, again, the only formula I'm really needing to know is that the a squared minus b squared, or bigger number minus smaller number. Other than that, if you know what they all represent, we're just going up and down and left and right that far from the center. Find the equation of an ellipse from its foci and vertices. So find the standard form of the equation of an ellipse with foci at -2 and 2, and vertices at 3 and -3. All right, so that, remember, the vertices and the foci, those are on the major axis. So we know, let's just actually draw a picture. We know 1, 2, 3, there's a vertex, 1, 2, 3, there's a vertex, and there are my foci. But I know that's my major axis, right? So it's got to be something like that. That's my longer one. So notice c squared equals a squared minus b squared. And so c is equal to 2, because that's how, remember, our foci are 2 away from the center. So I get 4 equals, a is 3 because we're 3 away from the center, 9 minus b squared. So I get negative 5 equals negative b squared, 5 equals b squared. So b equals square root of 5. So if I'm looking at this, I'm just going to have x squared over 9, all right, that's 3 squared, plus y squared over 5, that's the square root of 5 squared, equals 1. And I'm done. So these aren't too bad once you get the hang of it. At first it can seem overwhelming, but I think once you do plenty of practice, you won't think it's too bad to do. So translations of ellipses. If we translate, basically same thing as circles, same thing as parabolas, we're going to replace x by x minus h, y by y minus k, and we're just going to shift our new center to be at h and k. And it's easy as that. So all of this stuff here, translation of ellipses, I'll post a formula sheet with all this stuff, but realistically, it's not worth memorizing any of that stuff. Make sure you know what A is, what B is, what C is, and then just think of it all relative to the center. So let me show you. I'm not even going to look at any of those formulas or anything. We're going to go ahead and graph x plus 1 squared over 9 plus y minus 2 squared over 4 equals 1. So notice my center is going to be negative 1, 2, right? Because that's what makes this 0. 2 is what makes that 0. So there's my new center. Now, c squared is equal to bigger minus smaller, so equal to 5. So c is equal to square root of 5. And so basically, which one is my major axis? Well, yeah, the horizontal axis is my major axis because the 9 is the bigger number. So let's go ahead and come over here to negative 1, 2. All right, there it is. We know we're going to go left 3 and right 3 for our ellipse. So right 3, left 3. We know we're going to go up 2 and down 2 for our y's. And again, we know we're going to have to go left root 5. So root 5 is just over 2. So let's put it right there. And we're going to go right 5 just over 2. So it's there. Okay, that's an awful drawing, but you get the idea. And so where are the foci located? Well, notice, remember this point right here, we got the center negative 1, 2. Now, are we going up or down or left or right for the foci? We're going left to right. So I'm going to take that negative 1, 2. And I'm just going to go left root 5. I'm going to go right root 5. And there's my foci. So again, if you went through and filled out the sheet, you would have seen that it all worked out. But it's as simple as taking our center and realizing we're going to either add and subtract it to the x, if that's our major axis. We're going to add or subtract it to the y, if that's our major axis. There's a little bit of an error, I think. All right, so let's try another one here. Graph 9x squared plus 4y squared minus 18x plus 16y minus 11 equals 0. Where are the foci located? Okay, so again, that doesn't look anything like standard form. So how do we graph it? Well, we put it in standard form. How do we do that? You guessed it, our old friend complete the square. So let's just rewrite this as 9x squared minus 18x plus 4y squared plus 16y equals 11. Now I'm going to factor out a 9 here. Factor out a 4 here. So half of 2 is 1. Squared is 1. And so I add a 1 here. By writing a 1 there, I actually added 9. So I'm going to balance it by adding 9 to this side. Half of 4 is 2. Squared is 4. So I'm going to add 4. But that 4 gets multiplied by that 4. So I actually added 16. So I end up with 9x minus 1 squared plus 4y plus 2 squared equals 36. Now I need this to equal 1, so I'm going to divide both sides by 36. So I get x minus 1 squared over 4 plus y plus 2 squared over 9. And that's equal to 1. And now 1 comma negative 2 is my center. Right, from x minus 1 and y plus 2. So 1 comma negative 2 is my center. I'm going to go left 2 and right 2 for my co-vertices. Up 3 and down 3 for my vertices. So my major axis is vertical in this one. And now, again, c squared equals bigger minus smaller. So 9 minus 4 equals 5. So c equals square root of 5. This time I'm going to add and subtract square root of 5 from the y value of my center. So it's going to be negative 2. So 1 comma negative 2 plus root 5. 1 comma negative 2 minus root 5. And if I'm plotting those, again, root 5 is just over 2. So it'd be up there and right down there would be my foci. So again, take 5 minutes to read the application section on pages 963 and 964. But again, basically, one of the big things is like the orbits of the sun, orbits of the planets around the sun, and the sun would be located at one of the foci in that case. All right, so a semi-elliptical archway, so semi-elliptical just means half an ellipse, over a one-way road has a height of 10 feet and a width of 40 feet. Your truck has a width of 10 feet and a height of 9 feet. Will your truck clear the opening of the archway? All right, so let's take a look. Let's find out the equation of this ellipse. So notice we're centered at 0, 0. Notice we're going to have x squared over, so a is 20, right? So I'm going to have over 400 plus y squared over, and that's going to be over 100 because we're going up and down 10. That equals 1. So let's just, our truck has a width of 10 feet and a height of 9 feet. So will the truck clear the opening of the archway? So let's just see how tall the bridge is, or the tunnel is at when x equals 5, right? Because if the truck is 10 feet wide, if it's driving down the middle of the lane, right, it's a one-way road, so we're driving down the middle of the lane. So if it's 10 feet wide, it's going to go at 5 on each side. So let's let x equals 5 and see what y is on our arch. So 5 squared over 400 plus y squared over 100 equals 1. So I get 25 over 400 equals y, or sorry, not equals, plus y squared over 100 equals 1. Now divide top and bottom by 25 just to make it a little bit smaller and easier. So we end up with 1/16. All right, so let's add 1/16 to both sides. Y squared over 100 equals 17 over 16. Multiply both sides by 100. And square root. So y equals square root 1700 over 16. Let's go ahead and break out our calculator for that. Well, actually, before we do that, I noticed I made a little bit of an error here. Sorry, it's 1 minus 1/16, so it should be 15/16. And then that's 1500 over 16. And then it's square root of 1500 over 16. So, square root of 1500 over 16. You get 9.68. So, 5 feet from the center, the archway is 9.68 feet tall. So the height of the truck is 9 feet, so yes, it will fit. Because we found out how tall it was, and the truck was not that tall at that point. All right, so that concludes our section on ellipses.